The last type of factoring that we did was factoring by taking out a GCF. When we did that, all of our answers sort of looked the same as far as it was one term times a bunch of terms in the parentheses, right? It was one term and it was distributed, and what we did when we factored was basically undistributed it. All right, so now the type of factoring we're going to look at is our answer is going to end up looking like this: a binomial times a binomial. If we think back to last class, we were multiplying these together. That's what they wanted us to do up till now, is they'll say multiply those together, and we would, you know, do kind of that mega distribution I talked about, otherwise known as FOIL. Right? FOIL is really just an acronym to help us keep our multiplication organized, because everything over here needs to be multiplied by everything over here. That's what this is telling us to do. Multiply this whole thing by this whole thing. So F stands for first. We would multiply our first terms together. O stands for outside. We multiply our outside terms together. I stands for inside. We multiply our inside terms together. And L stands for last. We multiply our last terms together, right? So everything over here got distributed to everyone over there. Then we ended up getting like terms in the middle. So we went ahead and combined our like terms. And our answer ends up looking like this: x squared plus 5x plus 6, or x squared plus a number times x plus another number. When it looks like this, this is what we're going to focus on today. We're only going to look at, in this video, factoring a polynomial or factoring a trinomial when it looks like this, when it's in this form. When it's just x squared by itself, and then a number times x, and then a number. Okay? This is what we're going to do. So before, like I said, they gave us this, and they wanted us to multiply together, and this was our answer. Now they're going to give us this, and want us to factor it, meaning break it down into the two binomials that needed to multiply together to get us this in the first place. So we're going backwards now, all right? Which we can do if we follow some of the patterns that we see. So let's look at that. To get our first term, we had to multiply our first two terms together, right? When we did the first, we ended up with the first term here. We got our last term, 6, when we multiplied our last two terms in our binomials, right? So last times last got us last. And then our middle term came from when we did our outside and our inside products. Those ended up being like terms, and that'll happen every time. So in this case, we had to add them together to get our middle term. So when you have your outside and your inside products, they're going to be combined, added, or subtracted in order to get you this middle term. So using those patterns, we can kind of logically work backwards and figure out how this started as this. All right, so let's look at an example. All right, they're going to give us this now, and they're going to say factor. In our mind, when they say factor, first thing we're always going to do is check for a greatest common factor. These don't have any, so we can skip that. Then we look at it and see what other type of factoring we can do. Well, in this case, 3 terms, x squared, something x, something. So in our minds, we're going to say, okay, if I can factor this, it's going to look like this. All right? Because x times x, our first two terms need to multiply together to get me our first term here. So if I have x squared by itself, it's going to be x times x. Our last two terms multiply together to give us our last term. So I need two numbers that multiply together to get me 15. Well, that could be 1 and 15. Could also be 3 and 5. 1 times 15 is 15, 3 times 5 is also 15. So which combination do I need to put in here? So for that, we go to the middle term. Remember, those two numbers ended up being like terms. They needed to be added or subtracted in order to get the middle term. So I want the combination that's going to add or subtract somehow to get me 8. In this case, that's got to be 3 and 5. Right? 1 and 15 could get me 16 or 14 if I added or subtracted. So that's not going to work. So 3 and 5 is what I need in order to get 8. All right? The only way I can get positive 8 with 3 and 5 is if I have a positive 3 and I add a positive 5. So plus 3 plus 5. There's my binomials. Let's check. X times x should be x squared. 3 times 5 should be 15. 3 plus 5 should be 8. Okay? That's how you can kind of quick check. These two numbers need to multiply to get this, and add or subtract or add together to get the middle number. Okay? Let's try another one. All right. So I look at it, the directions are going to say factor, so I'm going to check for a greatest common factor. Spoiler alert, there is none. So then I'm going to see, oh, x squared something x something. That's going to look like this. Two binomials with x as my first terms, right? So now I know these numbers need to multiply to get me 24, negative 24, and add or subtract somehow give me 2. So I'm going to start listing the factors of 24. 1 times 24, 2 goes in 12 times, 3 goes into 24 8 times, 4 goes in 6 times, 5 doesn't go in, 6 we already used, so we know we're done. If you go in order like that, once you get to any repeaters, you know you're done, you know you've got all the factors, you're not missing any. Okay, so I need the combination that's going to now somehow get me 2 when I add or subtract. The only combination that's going to do that is 4 and 6, right? 8 and 3, if I add those, I get 11. If I subtract, I get 5, or negative 5, depending. So 4 and 6 is going to need to be what it is. So how can I get 2 with 4 and 6 when I add or subtract? Well, I'm going to have to do 6 minus 4. That would get me positive 2, right? So I know I need a positive 6 and a negative 4. All right, let's check. 6 times negative 4 gets me negative 24. Good. 6 and negative 4 gets me positive 2 when I add those together. So we can feel confident we have the right answer here. Okay? If you're not sure how to quick check, you can always just multiply them together, FOIL them back through, just like we were doing last class, and you should get this back. If for some reason you get the signs mixed up, if we were to put negative 6 here and positive 4 here, we'd still get negative 24 if we multiply, but in that middle term, we'd end up with negative 6 plus 4 would get us negative 2, and we want it to be positive. So if you get the right number in the middle, but the sign is wrong, you just mixed up your signs. So that's an easy fix. Just go back and check it. Go back and change it. Right? If you get the wrong number in the middle, that means you picked the wrong pair of factors of your last number. So for example, if I had chosen 12 and 2, right? 12 times negative 2 gets me negative 24, but 12 minus 2 doesn't get me 2, it gets me 10, right? Even if I switch the signs on it, it still doesn't work, right? Negative 12 plus 2, that's negative 10. So if I'm getting the wrong number in the middle, I know I picked the wrong pair of factors, so I have to go back. All right, let's look at 2 more things. 1, what if they make the x squared negative? Kind of throws everything off. If they do that, we want the x squared to be positive in order to do what we were just doing. So the quick fix to that is just factor out a negative 1, right? Divide the whole thing by negative 1. Take out negative 1, just like it's a greatest common factor. And then what that's going to do is it's going to change all these signs, right? If I divide by negative 1, now this is positive, this is negative, and this is negative. Right? Now it looks just like the ones we were just doing. So we can go ahead, bring our negative 1 down, but now factor this. So we got x and x. I need 2 numbers that multiply to get me 10. So 1 and 10, or 2 and 5. They need to get me 3 when I add or subtract them. Negative 3, actually. So the only thing that's going to give me 3 is 2 and 5. Right? 1 and 10 is going to get me 9 or 11. So how can I get negative 3 with 2 and 5? Well, if I had negative 5 and positive 2, that would get me negative 3. You might need to try a couple of them to see what's going to work. But now that I have it, I can just stick that right in. Right? Negative 5 times 2 gets me negative 10. Negative 5 plus 2 gets me negative 3. So I know this times this will get me back to here. And then if I multiply through by negative 1, I get right back what I started. Okay, so you need to keep that negative 1 with it, because remember, you should be able to multiply the entire answer and end up with what you started. Okay, so that's in that case. One last case. For all of these I've been saying, you want to make sure you check for a greatest common factor. None of them have had it so far. This one will. All right. You get one that looks a little scary. That might be a sign that you might want to check for a greatest common factor. So if I'm looking, I see that 2 can go into all of these guys. And this has x to the third, this has x squared, this has x. They all have an x. So I can take an x out. I can only take one x out though, because this one only has one. So once I take that out, then I've got x squared left, because I took one of the x's away, right? Minus 20 divided by 2, that's 10. I took an x away, so it only has one x left. And then 50 divided by 2 is 25. And I took the only x it had, I took that out. So that's what I have left over. So that's like the last video. All we did was take out a GCF. Now we want to look what's in here. Can it be factored further? Yes, because we see it's x squared, something x, something. So it can most likely be factored even further just by doing what we were just doing, right? X and x, so that's going to get me x squared. Need two numbers that multiply to get me 25, that add or subtract to get me 10. 1 times 25 will get me 25, and 5 times 5 will get me 25. But only 5 and 5 will add or subtract to get me 10. Right? Now keep in mind, I want a negative 10. So how am I going to get negative 10 with 5 and 5? Well, if I have negative 5 and negative 5, that'll get me negative 10. So x minus 5, x minus 5. Negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. So I know this will get me back to here. And then if I multiply through by the 2x, it'll get me exactly what I started with. Okay, so that's a good way to check to make sure that you factor correctly.